or maybe you get more energy. It means you get a lot of junction that's only not for design the broadband device, narrowband device. Focus on a very narrow range. You can then add them together. That's the good way. So that's published theoretical paper 10 years ago. So also you can see that's only for 3 junction device, very complicated. Only one layer is some have problems. They all devices very poor properties. So yeah, I think in China, no any university, no any institute can make this kind of device. Yeah, that's layer by layer, very complicated. Yeah, very delicate. Yeah, that's you have controlled the property each layer. Also, you have isolated spectrum. This 3 junction material, 3 devices should divide the solar cell by 3 pieces. Each piece should be isolated, but still not totally isolated. Because you have interface inside. That's technology used. That's concentrated light, then go to device. That's if concentration too high, usually how many times? 100 times, 400 times, 500 times, 1,000 times. If you want to reduce cost, it should be concentration. The ratio is 1 to more, very high, but very hot spots here will also damage the device if you not use a cooling system. That's around the world. That's especially in the European country. There are a lot of center for called 3rd generation solar cell research center to try to study the 3 to 5 multiple junction solar cell system. Yeah. Then the cost. At the moment, the cost is higher, but in the future, when concentration ratio is increased, the cost will go down. The expense will go. Also, typically, if the area, you not just cost how many dollars got how many energy, you have cost how many square meter got how many energy, because the area in the Earth is limited. Yeah, if you got the 10% efficiency or 50% efficiency, this means 5 times area, the smaller, you can get more energy. That's more important. Not just cost $1 how many energy, we have a cost per square meter how many energy you get. That's another fact. So we are trying to use another technology try to solve the problem. We can design a special filter, narrowband filter, to divide like the telecommunication. Can use the filter to divide solar spectrum 3 pieces, 3 range or more range. Yeah, that's solar can be divided efficiently by use the bandpass filter film device. Then each range we can use special, not multiple junction, use single junction. If we can find this junction or middle junction, very high efficient in this area, then got a very high conversion efficient for the device. That's this is three filters there. Problems for the loss for the filter. Filter we are not especially because we ask other center and the company made for us, not like the telecommunication. Telecommunication, they designed the filters very high, very low loss. Yeah, very low loss. They cut the telecommunication the range by 10 range, 20 range, 40 range, 100 range. Each range only 0.8 nanometer. Isolated very well each wavelength, but very high quality filter. But in the solar cell energy, we are not got so high. So still some loss. You can see that. You can see that's not 100%. That's lower. That's some loss, about 10% loss. Yeah, that's we try to use 4 filters that have got the 5 spectral range, 3 to 480, 400 630, 600 to 730, 700 to 870 nanometer range. because we cannot make a device. We try to find a commercial diode, looking for best commercial diode, which diode have very efficient in the special range can match to our filter. Yeah, this we found 5 diode from Hamamoto company. Yeah, that's each one we can get this. So that's not a wideband, it's narrowband. Here is very high efficient, very high. Yeah, narrowband. This is a simulator, solar spectral simulator. Then this optical system. That's whole solar energy radiation, but the lens focus on this is the filter. Filter the first device absorb part of them, and other spectral light then reflect. Because this filter no absorption, or 100% reflection, or 100% transmission, ideally, because the dielectrical the film filter. You can see that, yeah. Transmission 100%, then zero reflection. If this transmission zero, then 100% reflection. But why that's still cannot reach 100%? That's some device have not very good. I think that's what can improve in the future. Yeah. So we can one by one. That's if this short range is used up, the other long wavelength range, then go to second filter, then go to second device, then cut the other one. Let's go to the third one, fourth one, finally another one. Yeah, then we by the electricity voltage you can add together, calculate how many energy we get. It's calculation the ratio. That's conversion efficiency can add them together. That's incident power. That's we can calibrate by standing the solar cell. Then if other 5 solar cells, we can add them together, the power. Also, that's for IV curve change with the sun intensity measured can this. So that's add them together. 1, 2, 3, 4, 5. Totally more than 35% can reach it. Yeah. Otherwise, you use one device. You can I already show you. You cannot over 30%. Or but you use 5 or 4 that can above 30%, even more than 40%. I will discuss later. Yeah. That's a high efficiency of about 35.86% for total conversion can be achieved at the 2.8 sun radiation condition. That's a special condition. The problem for the diode. This diode not specially made for the output power. That's the output the photon to the electrical conversion, but cannot output power because they have the series resistance here. Ideal diode should be this is 0, this is infinity. But for this diode, that's the curve not very good. So part of energy we analyze for the pattern. Can see part of the energy power consumed internal resistance. So if this is 0, actually totally the power can achieve the 42.7 conversion efficiency. For the theoretical calculation for 5 junction, we calculate about totally ideal system can reach the 52.9%. The ratio close to the limit of this. If this one divided by this one, ratio is about 80%. Yeah, about 80%. But that's a diode not very good, especially for thermal contact. You should output the power, especially designed diode. That's not output power, output voltage. That's we bought especially from Hamamoto company. in the future, I think that's I will ask some people's help, some specially designed narrowband diode. Yeah, very good. Like if not multiple band diode, it's very difficult. That's a single junction diode easily. Yeah, reduce this internal resistance. This should be 0. This should be infinity. Yeah. So improve more in the future. First, reduce the optical loss by the improved filter design, like the WDM in the telecommunication. That's right now. This device is very well. That's very low loss in the device. That's reduce optical carrier loss due to the defect in the diode material structure. Also, the power loss due to internal resistance effect can be reduced. That's this is not our task. We are in the level. We cannot make that diode, but we can ask some research institute to help. They are specially can design a diode for this kind of application. Yeah. Individual the solid cell with the high quantum efficiency can be optimally designed to fit into the subspectral range. Overall efficiency, we hope we can more than 50% for the multiple junction, more than 5, maybe 5 to 10. That's we can achieve in the future. Yeah. Then heat dissipation, because you more diode, 5 to 10, you will not concentrate the heat to one diode. The energy will distribute 5 to 10 more diodes. That's each diode of single junction. That's will reduce the temperature effect, not to heat the sample too high, yeah, to the device too high. So to improve the performance of the system, that's very useful. Not otherwise you have to use special cooling system to cool the device. When temperature increase, even your efficiency very high, but the temperature increase, efficiency will go down. That's not very good. Yeah. So I think all this problem cannot be solved by one group. Should be several groups work together. Yeah, that's we just demo for the system. That's we can do these things, but we cannot go further. If we go further, we should several group work together. Some made the filter, best filter, or other way, or some the waveguide also can separate the spectral range. Then some group made a diode. What's the best diode? Narrowband, not a wideband. The narrowband only in the edge of the absorption gap. That's very high efficient. Yeah. Then also design the concentrate, very high efficient concentrate. Then other group design the system, put together. Then made a module. Yeah, made a module. That's then finally sell the module. Yeah, not just commercialize everywhere. That's very high efficient. Yeah, make module. Cost depends on the size. If material too very expensive, because 3 to 5 semiconductor material quite expensive. If you concentrate higher, yeah, material size is smaller, then cost will go down. Yeah. So in China, that's quite difficult because in our country, they are only follow the technology is matured, not go to new technology. Yeah, that's we few days ago. I came to here. We have another conference in the Jiangsu province near Shanghai. They are all talking about silicon, yeah, technology, solar cell, not discuss the third generation. That's I think that's in the future we should first generation only less than 10%. That's 8%, 9%. Only 1% difference. All companies fighting to each other. Yeah, that's improve only 1%. Yeah, how to improve 10%, 20%, more than 30%, 40%. Let's get more energy, but we should, for the university, we should go this way, not just the technology matured. I think mature industry got interesting, but the industry in our country is still very weak. We have not company not very good for R&D. I think that's the only some technology solved very in detail. That's a big issue. Yeah. So this paper we published last year, then cited this year's review article. That's this review article called splintered solar cell. That's also cited our results in this paper. This paper was published last year. So this is called spectral beam split for the efficient conversion of solar energy, a review, especially in last year. They are cited our results. So all this 2, 2, 3, this is 5 splitting, yeah, by separated solar spectral range by 5 pieces. I think we can get more. That's not only 5. That's, we have more. Got more energy, improve system. Yeah. So that's the review article reviewed last 10 years in this area. Use this kind of way to go to the real application. Maybe can solve the typical problem because you concentrate the multiple junction. Now only 3 is better. 4 is very hard. 5 is impossible right now. That's so. How about more than 5? Yeah, that's so they have a lot of references in the book. That's nearly 100 references in this paper.